Okay guys, so this is the third video, and really this isn't a lot of notes. This is mostly just examples for you of combination circuits. We're going to be using the same ideas we've been using the entire time. So I have listed the steps for how to solve combination circuits. Sometimes these will have little steps in between depending on the circuit, but we're going to kind of go in order. We'll start with a simpler one and then we'll go in order to a much more difficult one. So this way you have examples that you can look back on. Okay, so the first step, and we're going to follow these steps as we go through this circuit, but the first step is to draw the circuit if it's not already given, but we have it here. We're going to combine all resistors into one and draw the simplest form of the circuit. So that's the first step. So the simplest form is back to our just the battery or the factory and one resistor. In order to find the total resistance, first we would want to combine these parallel resistors. So we'd have to go 1 over 20 plus 1 over 10 plus 1 over 10 equals 1 over R total. And if you do that, you get the R total to equal 6 ohms. Oh, sorry, I'm sorry, 4 ohms. And that's for the total of the parallel circuit. And then we'd have to combine, once this is done, we have a circuit that looks like this. We have the 2 ohm resistor, and the combined resistance here of 4 ohms. And then once we combine these two, since these are in series now, those would just add up, 2 plus 4. And we get our real R total, this is the parallel, real R total would be 6 ohm. Okay, and so we want to put our totals. So it says use Ohm's law to find total current on the main road. So right now we know our total voltage is 12 because that's what's coming out of the factory. That's the number of cookies in each truck, remember? We have our total, which is 6 ohms for the whole circuit. And the reason we need to find that is in order to find the total current on the main road. In order to do that, we're going to use V equals IR. So it'd be 12 equals I times 6, and if you do the math, I is 2 amps. Okay, that's our I total. So that was step 3. Now step 4 is to look back at the original circuit, so that's this here, and note any resistors that all the trucks must pass by. So if you look, if the current is going this way, it can take one of 3 roads. So not all the trucks are going to go over every road, so those ones are not the ones we're talking about. But when the trucks come out from whatever road they chose to follow, they will have to pass by this 2 ohm resistor. You'll notice that it's the same case if the current were to come out from the other side. All trucks would still have to pass this 2 ohm resistor. So we know that this one has to get all the current, which is all the trucks, so 2 amps. So if we label this resistor 1, then we look at resistor 1. Sorry, I got interrupted. So if we look at just resistor 1, we know the resistance on it is 2 ohms. We know the current that flows past it must be all the trucks, which is 2 amps. And from that, we can use our Ohm's law to find the voltage. So we know that 2 times 2 is 4 volts. Now, because this resistor is going to take 4 volts, that means that these 3 resistors don't get all the 12 volts. So we just figure out how much is left for each of these 3. Remember, since these are in parallel, all 3 of these will get every volt. They'll have the same voltage. They'll have different currents, but they'll have the same voltage. So because this resistor is definitely going to use 4 volts, we have 8 left to go over this one, or this one, or this one. Remember, the trucks can only take one path. So we know, and let's call this one 2, 3, and 4. So we know in resistor 2, we have a resistance of 20 ohms. We know the voltage is 8 volts. And from that, we can find the I. So essentially, we just do 8 divided by 20, and we get 0.4 amps through that resistor. Same idea with number 3. Since the voltage is the same because these are in parallel, we know R is 10, voltage is 8, and I is 8 divided by 10, so 0.8 volts. Oh, sorry, amps. Since 4 and 3 are the same resistance, and we know their voltage is the same because they're in parallel, their I will come out to the same math. Okay? So that's how we can solve for all the things that we could possibly be asked for in every single resistor throughout that circuit. Okay, and we did follow all those steps from the top if you go back and look. Okay, let's go to another one. Okay, now on this one, I want you guys to first just cross out this resistor. We're going to do one like that, but I want to get rid of it for this problem. Okay, now this resistor is drawn sort of strange, and it's hard to tell which ones are in parallel and which ones are in series. So what I want you to think about is if trucks are coming out, okay, they have to pass by this resistor. Okay, then they're going to go through, and they can either go this way and come back to the battery, or they can go this way and come back to the battery. They cannot make loops, okay? So they can only go one direction. So they cannot go from this one up to this one. They can't go from this one back to this one. So they're going to pass by either this one or this one, which means that those two are in parallel. So I want to redraw the circuit so that it looks like something we've seen when we know that those two are in parallel. So if we draw it like this, that gives us a little bit better picture. And you can put, doesn't really matter which one you put where, but if we put the 1000 ohm resistor here and the 1500 ohm resistor here, and this one is still 250 ohm. Okay. So first step in combination circuits is to find the total resistance. We know the total V is 10 because that's what's coming out of the battery. Okay. And the total resistance, we would first go ahead and add these two parallel guys up. You can't add the series with the parallel until these guys are condensed into one. So first I'm going to add these by doing 1 over 1000 plus 1 over 1500 plus 1 over R. These are the parallels. Okay, and if you do that, you get, let's see, 600 from the parallels. You get 600 ohm. Okay, so now the circuit would look something like this. Okay, and now these are in series and we can just add them straight up so that we can end up with just a simple circuit like we'd like. And these two would be 250 plus 600 is 850. So our total is 850. And if that's the case, then I total is 10 divided by 850, which would give us 0.12 amps. Okay. Now that we have those numbers, okay, we have to look back at our original circuit and figure out which of the resistors do the trucks have to pass by, all the trucks. So if they go this way, which they will because it's the positive side, but if they go this way, they have to pass by this resistor. They have to pass by this truck. All of the trucks have to pass by this house. Even if they were to go this way, and it doesn't matter which path they take, they have to go by this house. So since they have to, all the trucks have to go by this house, this gets the total current in the circuit. So we're going to label this, well, it's already labeled R1. So R1 gets all the current from the total, so 0.12 amps. We know the R is 250, and we're going to figure out how much voltage is dropped across that house. How many cookies do they take, basically? And so we just go I times R, and we figure out that the voltage drop is 30 volts, okay, in that first house. Now, since 30 of the cookies are dropped at this house, that means there's only 70 cookies left for either this house or this house. Okay, the trucks can't go to both, remember. So 70 here or 70 here. So let's look at resistor 2. That's this one here. Okay, we know the resistance is 1500 ohms. We know the voltage drop is going to be 70 cookies or 70 volts. And we can find the current using Ohm's law. So 70 divided by 1500, we get 0.047 amps. Okay. Now this was resistor 3 that we crossed out, so this is resistor 4. So since the trucks can either go here or there, this one's also going to have a 70 volt drop. We know the resistance is 1000 ohms, and we can use V equals IR, so 70 divided by 1000 to get our current, which is 0.07 amps. Okay, and now we've established all the values for all the resistors. Okay, let's do one more. Okay, this one is a little bit harder. There's a little trick here because these are in series and then they're in parallel with this one. But let's just start with the first task, which is just to combine all the resistors. Okay, we know our V total, I'm going to put it up here, is 40 volts because that's what's coming out of the battery. Okay, and then if we combine the resistors, first we need to combine these into series. Okay, so 8 plus 2 is 10. So we have a circuit that looks like this. Okay, where this is 10 ohms and this is 10 ohms. And this is 5 ohms and this is 40. Now these are in parallel, so we'll combine them as 1 over 10 plus 1 over 10 equals 1 over the R total for the parallels, okay, or just put P, whatever you want to do. Okay, the total there would be 1 over 10 plus 1 over 10, and so when you get the R there, it would be 5 ohms. Okay, so our circuit ends up moving to look something like this, where this is 5 ohms and this is 5 ohms. And now these are in series, since you can drive trucks past both, okay, without switching streets. So we know these are in series, so the resistors in series added together would give us 10 ohms total. So we know that our total R, if we go back to the top here, let me spread this camera out a little bit so you can see the whole page here. Okay, our total R is 10 ohms. And now we can find our total I from the Ohm's law. So 40 divided by 10 gives us a total I of 4 amps. Okay. Now, the next step is the same as in the previous examples. We know that this resistor, this house, has to get all of the trucks by it, whether it goes this way, or if the current goes this way, or if the current goes this way. Okay. So this one gets all the trucks, which means it gets all the current. So let's label this number 1. Okay. And number 1 is going to have a resistance of 5. It's going to have a current of 4. And the voltage would just be those multiplied, so we get 20 volts. If this house is going to take 20 cookies, that means there's 20 cookies left to go either this way or to go this way. So if we just go to this next one here, we'll label that one number 2. It's just like the previous problem. We know that there are 20 volts, 20 cookies left. Okay, and the 20 cookies left, sorry about this, the 20 cookies left go to this resistor, so we know the voltage is going to be 20, we know the resistance is 10, and we find R, we get 2. Okay, now 3 and 4 are a little more difficult. And the reason they're more difficult is because there's 2 separate resistors in series, but we know that the total cookies that has to go to both of them is 20, because that's what's left. This took 20, and if a truck decides to go this way, then all 20 have to go to these resistors, but you can't give 0 to anybody. So what we have to do is we have to figure out what the current is across here, how many trucks go across here, and then we'll break those up evenly amongst these guys. So we know there's 20 cookies to spread out across this. We know together their resistance is 10. So we want to figure out what the current is, or the number of trucks that pass by these 2 resistors. The same number of trucks will pass by this one as pass by this one. So what we do is we go back to this picture where they were combined, and we figure out how much current is across this leg of the road. Okay, and we know that there are 20 volts across there. So 3 and 4 together are a resistance of 10. The voltage across them is 20, and so the I is 2 amps. Okay, now there's 2 amps across here, and there's 2 amps across here because the current is the same across series resistors. Okay, so we know that the resistance for 3 is, we'll call this one 3, is 8. We know the current is 2, and the voltage then has to be 16 volts. For 4, we know the resistance is 2. We know the current has to be 2, and so the resistance is the voltage is 4 volts. Okay, we can go over more like this in class, but make sure that you have those down and write any questions down that you have so that we can go over it when we have class. Okay, see you guys soon.